So the next thing we want to do is try and visualize some of that data that we've got. We'll start with the Nobel laureates, and we'll demonstrate some of the sort of built-in visualization tools that Pandas has. So Pandas has some of its own sort of convenience methods for plotting, for doing sort of basic plots, but as I've mentioned, it's really a wrapper around matplotlib, so that we can use matplotlib to annotate our plots, for example, to do things like change the titles and the labels and the ticks and so forth, legends, all that kind of thing. Pandas plot just does some of the basics for us. If we want to do something more elaborate, we can use, of course, matplotlib directly. So let's start by having a look at prize nums. That's this one here. So we've put all of our data into, read in our data, put it into a correct numerical format. Let's see what, so prize nums is our data frame. So plot.bar is our method here. So let's see what Pandas will do by default if we ask it for a bar plot. Okay, so as I said here, it tries by default to plot all the numerical columns, and there's a number of methods in Pandas that do that. If you call it, it'll just try and do all of the numerical columns if you don't specify. This doesn't produce a particularly good plot for us because firstly, obviously the scale of population is much larger than the scale of the Nobel laureates, or the laureates per 10 million, so that dominates the plot. And secondly, we don't know how these relate to the countries, so this doesn't really tell us very much. So the first thing we want to do is we want to relate the data to the countries. Okay, so the plot.bar allows us to put in what we want on the x-axis and what we want on the y-axis. So let's go ahead and plot Nobel laureates against the entity or the country they belong to. Okay, so getting better. So now we've got our entities or our countries along the bottom here, and here we've got the total number of Nobel laureates. Now, as we saw way back in one of our first visualization case studies, when you're trying to look at the relationships between categories like countries, it can help to sort the data so that we can see where they lie in a progression. And so we'll do the same thing here. Once again, Pandas provides us with a sorting method because that's, again, such a common operation that we don't need to do it separately ourselves. So we're just going to use Pandas sort values method. I won't go back to the API each time we use one of these methods, but you can have a look, and obviously when you're doing the lab work, you'll need to look up the API to see what the method is and what arguments it takes. Okay, so in most cases there's quite a few arguments that you have a choice of. Here, Nobel laureates here is going to specify the column that we're going to sort on. I think we could also specify a list there so that we sort on the first thing and then within that on the second thing and so forth. We're going to do it in descending values, so ascending equals false, and we're going to do it in place, so we're not going to create another data frame, we're just going to sort it in place. It makes sense here because we're not really altering the data frame, we're not altering the data in any critical way, we're just rearranging it. And then we'll do our bar plot again. Okay, so that gives us a better picture because that gives us a ranking of the countries. This is a ranking in terms of the total number of Nobel laureates, and you can see that United States here really leaves the rest behind in terms of total Nobel laureates, with United Kingdom, Germany and France following up. United States is by far the biggest. For the data down here, we can't really we still get the ranking here, but we can't really see a lot, and it's a bit crowded. So we can, of course, zoom in a sense by just taking part of that data. So we could take the left part and look at it in more detail. We could take the right part and look at it in more detail by masking out the higher ones. So we'll just to demonstrate that, we'll look at just the ones with more than 2 Nobel laureates in more detail. Now it's important to look at what we're doing here, because I'm really doing about 3 things in one go. Okay, so what I'm doing is I'm firstly getting out the Nobel laureates column. Okay, so I'm extracting the Nobel laureates column, which we know gives us a series. Okay, then I'm going to compare that with 2, and that's going to give us a Boolean series. Okay, so it's going to be true for all the ones in that series that are greater than 2. And then I'm going to use that Boolean series to mask out the data that we want from prize nums, so from the whole data frame. Okay, so we've done 3 things in one go, and it's quite a common structure, this. So we've got out the column as a series because that's what we want to use as our decision information. Yeah. Then we've made our decision by comparing that. In this case, we've just compared it with 2. So we've got true for all the things greater than 2. That gives us a Boolean series, which we can now use as a mask to get out the rows of the whole data frame. Okay, so we end up with the rows of the whole data frame, but we've masked it using that Boolean series. Then on that, we're going to call our bar plot, and we're just going to extract the things that we want to plot, which are the Nobel laureates against the entity as before. Okay, so important construction to understand, and that gives us a much better plot. It's much less crowded. We can see that the dominance of the United States in terms of total number, UK, Germany, France, and the rest. It's nice to see that Australia gets in there. And of course we could do the same with the right hand side to expand those out. So that's the total number of Nobel Prizes per country. Let's have a look now at the per capita data. We know that our laureates per million is essentially a per capita figure. Laureates per 10 million. Effectively it's multiplied by 10 million, so that instead of getting a very small fraction of prizes per person, we get prizes per 10 million, which is just an easier number to deal with. Okay, so what we're going to do is we're going to sort it, resort it by laureates per 10 million, and then we're going to plot laureates per 10 million against the entity. Okay, so we get a very big, very different picture, and now the Faroe Islands stands out as the big achiever, way ahead of everybody else. The United States has dropped to here. the big achievers are Faroe Islands and St. Lucia. And then we see that actually the Scandinavian countries do pretty well here before we get down to the UK and later the United States. We can also compare two or more columns within our bar plot. So what we're going to do now is plot. So again, we're going to expand it out so that we just have the biggest ones, and we're going to plot all of those where the laureates per 10 million, so that's our per capita figure, is greater than 5, and we're going to plot against the entity on the x-axis. We're going to have two things here on the y-axis. We're going to have the number of Nobel laureates and the number of Nobel laureates per 10 million. So combining those two things that we had earlier. So let's do that. Okay, so now we've got our in orange here. Notice that Pandas also nicely creates a legend for us by default. So laureates per 10 million in orange, and we've got that against the total number of Nobel laureates. On that criterion, we find that unfortunately Australia doesn't make the cut there, but New Zealand does, so go New Zealand. Okay, so that's basic plotting using Pandas and using our Nobel laureates data. Before we leave this section, what we want to start doing is looking at some of the relationships in the data and go back to answer some of those questions that we asked at the beginning. So we can use the visualization tools just to start looking at those relationships. So just as an example of that, we'll start with the relationship between size of country and number of Nobel laureates, and see whether we can see a relationship. So we know that when we look for those relationships, often we use a scatter plot to see if we can visualize a trend there. So let's look at the scatter plot. Again, Pandas provides us with a scatter plot function, and we just have to name the columns. Okay, so that's our relationship, and it's really not very clear what kind of relationship that is. We've got some three really big outliers here. We could look back, we could work out what those are. But let's zoom in on this bit here just to see whether it offers us any more information by removing those three outliers. So all three of those have a population greater than 300 million. So let's try just masking those out. So again, we're going to use that same structure that we used before. As I said, this is quite a common structure. So very, very convenient and quite powerful. So here we're taking out our population as a series. We're comparing that with 3 million. We get true for those that are smaller. We're using that to mask the data out of prize nums, and then we're calling this the scatter method on the masked data frame, the remainder of the data frame. So let's just give that a go. Okay, so there we've got, we've expanded that bottom corner out, but it's still not particularly clear there what sort of relationship there is. if any significant relationship. So we're going to start looking at those relationships in more detail. In particular, we want to look at relationships between Nobel laureates and the chocolate consumption. And to do that, we need to merge the data from our two tables. So we've got one table which has got our consumption data, one table that's got our prizes, and we're going to look at merging those together in order to examine the relationship. So that will be next.